All right, today we're going to review a couple things from Unit 1B. So the first problem in your warm-up has a picture of two graphs. And I wanted to look at this again because I noticed on the test for this unit, a lot of people assumed, or not assumed, a lot of people thought that the solutions to the system were these two spots where the graph crosses the x-axis. That would be those would be the solutions if we were just talking about that one function being graphed. But when we're talking about two equations or functions being graphed, then when I ask you to find solutions to a system, or if there are two or more graphs on one coordinate plane, we're looking at where the two graphs cross each other, not where they cross the x-axis. So the two solutions to this system would be here and here. And to estimate, notice it says estimate, you might not be able to get the exact numbers. So when it says estimate, you're taking an educated guess at where those solutions are. So let's look at this one. This one appears to be a little past 3 in the x direction, so maybe 3.1 for your x value. And then the y value is just above 1, 2, 3, 4, 5, just above 5, maybe a little further than it was over the 3. So I'm going to say 5.2. You may estimate a little bit more, a little bit less, but if you just said 3.5, that would be incorrect because it's obvious that it's not at the point 3.5. So you need to estimate a little beyond the actual closest point on the graph. And then in this one, you would go back, so we know it's the negative, and it's just past -1, so we could say -1.1, and it's going positive in the y direction, 1, 2, 3, 4, 5, 6, 7, a little over 7, maybe 7.3. So there's your estimate. That's all you have to do for that one. For the second one, it says to graph the two equations. So go ahead and put those two equations in your calculator. I'm pulling mine up. And I still have those in there from earlier. Yeah, x cubed minus 4x plus 6 and 2 times 3 to the 2x minus 1. That's what you want to have in your y equals menu. Then you press zoom 6 or just graph it, and you've got the two functions right here. You can find those, the coordinates of those, the calculator will give you the coordinates of those if you just hit second, trace, number 5, intersection. You want the intersection. And then just make sure the spider is close to the point you want to find and press enter until it says guess, and then tell the calculator to guess. So that intersection would be at -2.6 because we round up, and this one would round up to -1 because 0.99, that rounds up to 1. So -2.6 and -1 are your coordinates of the first point, and we have to go back and do it again for this point. So we're going to hit second, trace, number 5, and then use your cursor to move that over to the second or closer to the second point, and just press enter 3 times. Come on. Okay, then that one is at 0.4 and 4.3. So 0.4 or 0.4 and 4.3. So two solutions to that system. Okay, so now to your notes. I'm going to skip that. Your notes. Recall that the absolute value of a number is the distance from 0 on the number line. So here we have a number line, and we're looking at a number. The absolute value of some number is equal to 7. Well, if the distance from the number line of this number has to equal 7, we know that this number has to be either -7 or 7, right? So in this case, x equals 7 or x equals -7. Well, the same thing would happen if I put maybe x plus 1 inside the absolute value. if I said the distance of this quantity, the absolute value, or this distance of this quantity from 0 on the number line has to equal 7, we know that x plus 1 has to either equal positive 7 or that has to equal negative 7, because that distance from the number line has to be 7. So, or from 0, I mean. So if I solve this, subtract 1, I get x equals 6. And if I solve this one, I get x equals negative 8. So for an absolute value function, because it's the distance of the number line, so it could go in either direction, it will have quite often two solutions. You do want to check your solutions to make sure they make, so I would plug the 6 back in. Up here, 6 plus 1 is 7, the absolute value of 7 is 7. Negative 8, negative 8 plus 1 is negative 7, the absolute value of negative 7 is 7. So both of those are valid solutions. So let's try one. We have that 2 times the absolute value of x plus 1 equals 8. Okay, so your first step in any of these types of equations, no matter what type of equation you're trying to solve, is to isolate whatever the function is. So we're going to isolate the absolute value. Okay, isolate the absolute value. So you need to look at it. What is going on here? I have 2 times the absolute value of x plus 1. So to undo multiplication, I use division. So I'm going to divide both sides by 2. If this was absolute value of x plus 1 with a plus 3 on the outside, then you would have to subtract 3. You always undo the same way you would in any type of equation, using the opposite operation. So 2 divided by 2 is 1. So on this side I have x plus absolute value of x plus 1, and 8 divided by 2 is 4. So I isolate the absolute value. Now, thinking about what I did back here, after I figured out that the distance from the number line was 7, or the distance from 0 on the number line of this quantity has to equal 7, I knew that the quantity had to equal 7 or negative 7. So notice I no longer had absolute value bars here. So the next step is going to involve dropping the absolute value bars, and then set or create two equations. One positive and one negative. Now, these steps you are free to write in your own words, however it makes sense to you. I'm just giving you ideas of what to write. You don't have to write exactly what I wrote. Write what you know you will remember. So now I'm going to make my two equations. So I have x plus 1 equals 4 and x plus 1 equals negative 4. I've got those two equations, and the last thing you're going to do is solve and check. So to solve, I have, I'm going to write it again so it's in the correct box, and subtract 1 from both sides. So I have x equals 3, subtract 1, and this is x equals negative 5. Check those solutions. If I put 3 in, 3 plus 1 is 4, absolute value of 4 is 4, negative 5 plus 1 is negative 4, and the absolute value of negative 4 is 4. So these solutions are both valid. Okay, so I want you to stop the video, try the two problems down below, down below, and then come back and check to see if you did them correctly. So this one is 3 times absolute value of x minus 6, so I'm going to divide by 3. And I get absolute value of x minus 6 equals 4. Drop the absolute value bars and create your two equations. So x minus 6 equals 4, and x minus 6 equals negative 4. Add 6. X equals 10. Add 6. X equals 2. So the solution to that are 10 and 2. Check 10 minus 6 is 4, and that's 4 times 3 is 12. 2 minus 6 is negative 4. Absolute value of negative 4 is 4 times 3 is 12. Yes. Okay, and then the second equation is, I'll do it in a different color. 2x, absolute value of 2x minus 1 plus 3 equals 6. So undo that, plus 3, minus 3, minus 3. So you have absolute value of 2x minus 1 equals 6 minus 3, which is 3. Okay, we're on step 2 now, so we're going to drop the absolute value bars and create our two equations. 2x minus 1 equals 3, and 2x minus 1 equals negative 3. Add 1, 2x equals 4, and divide by 2. X equals 2. Add 1 and divide by 2 on this side. Let's check those. So if x is 2, 2 times 2 is 4, minus 1 is 3, plus 3 is 6. If x is negative 1, 2 times negative 1 is negative 2, minus 1 is negative 3. Absolute value of negative 3 is 3, plus 3 is 6. So those are good. Okay, at the same time, we also need to be able to solve absolute value inequalities. We wrote some of those yesterday, and now we're going to practice solving them. So for the same reason as absolute value of x equals 7 had two solutions, absolute value of x is greater than or equal to 4 also is going to have two solutions. So let's think about it. Let's make our, here's negative 4 and here's 4. So if that were equals, we'd know that 4 and negative 4 would be the solutions. But it's greater than, which means the distance from 0 on the number line has to be greater than 4 units. So remembering when you used to graph inequalities, we would put a solid circle there because there's an equal to there. I know it has to be greater than 4. The distance has to be greater than 4. So in here, these would not, none of these distances would be greater than 4. So this means this has to be going this way, and on this end it would go this way. So now we know x is less than or equal to negative 4, and x is greater than or equal to positive 4 would be the solutions to this function, to this equation, or inequality. So what if I put an x plus 1 in there? Would it work the same way? Well, yeah, because the distance still has to be greater than or equal to 4. So we'd write x plus 1 is greater than or equal to 4. And now we notice we flipped the inequality sign. X plus 1 is less than or equal to, and then put a negative 4 here. So that step's a little different because you don't have an equal sign. You still put a negative here, but you'll flip that inequality sign. So you have negative 1. X is greater than or equal to 3. Subtract 1. X is greater than or equal to negative 5. Check. If I put 3 in for x, 3 plus 1 is 4. Yes. Negative 5 plus 1 is negative 4. Yes. And you might want to pick one number even further, like put 4 in. A number greater than or equal to 3. If I put 4 in, 4 plus 1 is 5. That works. Greater than or equal to, whoops, I wrote that wrong, didn't I? X is less than or equal to negative 5. A number less than negative 5 would be negative 6. Negative 6 plus 1 is negative 5. Yes, that works. So there you go. Okay, so in general, your first step is still going to be to isolate the absolute value. So on this, this is a negative 1/2 absolute value of x minus 2. On your notes, you couldn't see the negative. Is less than or equal to 5. Okay, so I want to first of all remember when you are working with absolute values, solving the equations, when you multiply or divide by a negative, you flip the inequality sign. If you remember that rule back from Math 1. Okay, so to solve this one, I have to multiply by the reciprocal of this number on both sides. So I will multiply by the reciprocal of negative 1/2. Well, the reciprocal of any number is still going to have the same sign. So the sign of the reciprocal of this is negative 2, or is negative. And remember, the reciprocal of negative 1/2 would be negative 2 over 1. So I don't need to really put the 1. You can if you want. And then on this side, it's times negative 2. Okay, so now this equals 1 when I multiply it all out. So I have absolute value of x minus 2. Remember, this flipped because I multiplied by a negative, so greater than or equal to negative 10. Create or drop the bars and create your two inequalities. Two inequalities, one positive, one negative, and then don't forget to flip the bar. I mean the sign. Don't forget to flip the sign for the one that you flipped the positive or negative. When you made one negative that was positive or one positive that was negative, that one you also flip the inequality sign. So in this case, notice this number is negative. So that's why I wanted to qualify that. So I'm gonna write, kind of separate that out. Okay, so my first one, x minus 2 is greater than or equal to negative 10. All I did was drop the bars. In this one, I do x minus 2 as less than or equal to positive 10. Add 2 to both sides. We'll solve and check. Solve and check. So add 2 to both sides. I get x is greater than or equal to negative 8. And if I add 2 to both sides of this one, I have x is less than or equal to 12. Now let's check these. Number greater than or equal to negative 8 might be negative 7. So let's put negative 7 in. Negative 7 minus 2 is negative 9. And the absolute value of that is 9. 9 times negative 1/2 would be negative 4.5, which is less than 5. Greater than negative 8. Let's look at this. Here's 12. Here's negative 8. So we're looking at the numbers in here. Let's put 0 in, because if 0 works, we pretty much can tell all those numbers are going to work. So negative 1/2, absolute value of 0 minus 2 is less than or equal to 5. Well, let's see. 0 minus 2 is negative 2. Absolute value of negative 2 is 2. So negative 1/2 of 2 is negative 1. That's less than or equal to 5. So I think we're good here. The other one I had incorrect in my head. Okay. So you go ahead and do the problems, and then stop the video, come back after you've finished doing the problems. Okay, so the first thing I'm going to do here is divide by negative 2, which flips the inequality sign, so x plus 4 is less than or equal to negative 8. Absolute value of, oops. So this is x plus 4 is less than or equal to negative 8. X plus 4 is greater than or equal to 8. So we've got subtract 4. X is less than or equal to negative 12. Subtract 4. X is greater than or equal to 4. Let's check that. So it's going to be greater than negative 12, less than or equal to negative 12, greater than or equal to 4. So a number less than negative 12, negative 20. Let's try negative 20. So negative 2 times negative 20 plus 4, is that greater than or equal to 16? Negative 20 plus 4 is negative 16, which the absolute value negative 16 is 16 times negative 2 is negative 32. Is that greater than or equal to 16? No. X is greater than or equal to 4, so is it 5?